last time slot of the day, so try not to fall asleep. Hopefully a little live coding will perk everybody up, so I will turn it over to Mary Rose.
Hello. Can you all read that text that is up there? I can make it bigger. Yeah, okay. So I'm going to make Space Invaders from scratch in JavaScript using no libraries. The idea behind this talk is to, I guess, demystify things like drawing to the canvas and getting keyboard input and doing sound in the browser. I think it's pretty tempting to use libraries when you try to make your first game, especially if it's on the web, and I don't think that's necessary at all. All the low-level stuff is actually easier, I think, than doing the high-level stuff for a game. So let's get started. So I've got a index page here, just some HTML, and I'm going to load my source, which is just all going to live in this game.js file. And then I'm just going to go right ahead and add a canvas tag, which is where we'll be drawing the game, give it an ID so that it can grab it back out in the code to draw to. I'll give it a width and a height, which will be the width and height of the screen that we'll be drawing to. So that seems fine. So that's most of the HTML. The rest will be JavaScript. So we're here over in the game.js file. I'm just going to console.log hi, just to prove to myself that we've got something running, and there we have. So you can see hi down there in the console. So it seems like the code's being loaded and run, which is great. Let's write some game code. I'm going to make a constructor function which will instantiate the game. And I want to run that when the browser is, or the DOM is ready. So I'm going to listen for the load event, which will get fired when my script has been loaded and when the canvas is ready to be drawn to, and things like that. And so in here I can just go ahead and instantiate my game. Now back in the game constructor function, let's try and get something on screen on the canvas. So I can just use getElementById to grab the canvas element. And then I can call getContext on that, passing in 2D. And that's just like some kind of an incantation that gives me screen, which is just a bag of functions that I can use to draw to the canvas. So for example, I can call fillRect and pass in the x and the y coordinates of the top left hand side of the rectangle, and then a width and a height, and that will draw a rectangle on screen. So it looks like the canvas is hooked up nicely too, which is great. Now, because this is, Space Invaders is a real-time game, then we need an animation loop of some sort. So I'm going to make a function called tick, which its job is to handle the main animation loop of the game. And all it does is just calls update on the game to update the game state, and then calls draw on the game to draw the current game state. We'll call it once, just down here. And now those functions don't exist yet, so we've got to create them. So I can just create them as methods on the game prototype. So update and draw. Now, just for a second, I'm just going to say drawing, just so while I get everything glued together, and we'll see what happens. So it prints out drawing once, which is very nice, but not what we want. We want to call drawing many times because we want to call the tick function once and then many times a second for the rest of the game. So there's a nice way to perpetuate that tick function, and it's this browser API called requestAnimationFrame. And you just pass it a function which you would like the browser to call again in the very near future. So now the flow is call tick once, then call update on the game, draw on the game, then request animation frame to schedule the next call of tick, which will then, of course, come back around here to update and draw and schedule the next version and so forth. And the browser promises to try and give you 60 frames a second if it has the resources to do that. So if we go back to the code, then we can see that drawing is being printed out a ton. So we've got some sort of animation loop going, which is great. Now let's get something a bit gamey on screen. Stop that running. So I'm going to make a player constructor function to instantiate the player, and that takes the game object, and we'll go right ahead and save that away on the player object for later use. And then the player is going to need a size, which will be 15 pixels by 15 pixels, and then they'll need a center for where they are at the moment in the game. So they'll start out as right in the center of the screen along the x-axis, and then just near the bottom of the screen on the y-axis. So obviously to make those work, then the game needs a center and a size. So let's fix that. So the size of the game is just the size of the canvas. And then the center of the game is just the center of the canvas, so half the size in each direction. So that feels good. Okay, I've got a syntax error, line 4. Oh, thank you. Great, thanks. Okay, so now though we want to figure out how we're going to draw the player, and just to keep everything simple, then everything's going to be drawn as a square. So the player, the invaders, and the bullets are all squares. So I'm going to make an update and a draw function on the player, and this is a pattern that will be repeated throughout the code. So everything that you care about has an update and a draw function that you can just blindly call, and then it will update or draw itself in the way that it knows how. So given that we're going to do the same drawing for every object in the game, then we can use the same function to do that for us. So I'm going to make a draw body function, which just takes the screen and a body to draw, and then just uses the dimensions, the size and the center, to go ahead and draw it. So draw body is pretty simple. Just uses fillRect, our old friend. So fillRect works from the top left, so we can't use the center, just on its own. And then the width and the height of the rectangle is just the width and the height of the body. Cool. Okay, great. Now though, we need to instantiate the player, and we need to get update and draw being called on them. So the instantiation, we're going to have this array of bodies, which will be all the bodies in the game. So the player, the invaders, and the bullets. So we'll start that off with just a player inside it, passing in the game. And then we just want to call update and draw on all of our bodies just blindly. And so that's pretty simple. We can just iterate through all the bodies. And call update on each one. And then we can do the same for draw. Cool. Okay, so let's see where we are. Got the player on screen. So that feels nice. Now let's get the player moving. So I'm going to make this keyboarder module, which is just a constructor function, which is just going to keep a record of every key on the keyboard that's down right now, and then provide a function for some outsider to interrogate that state whenever they want to. So the state of the keys will be kept in key state, just an object. And then I'll bind some events. So the first event I care about is the key down event, which is run when a key goes down and then on keyboard repeat as well. And so if I bind to it, then my callback function will receive an event E, which it can look up which key was pressed. So I can just say, hey, let's update in key state the key that was pressed and set it to true. And key code is just an integer which uniquely identifies a specific key on the keyboard. So for example, the left arrow key is 37, the right arrow key is 39, and so forth. So that's the key downs. That's all good. Now let's do key ups. This tells us when the key stops being pressed, so we can update the state. And then we just want a nice function to allow interrogation of the state. So that takes a key code, of course, and we just return the entry in the key state and whether it equals true. Okay, great. So now we can just use the keyboarder on the player. Now remember, this update function on the player is just going to be run many times a second, hopefully 60 times a second. So we can just ask the keyboarder what's going on. So we can say, hey keyboarder, is, let's say, the left key down? Now that's not going to make any sense yet because we don't have a bunch of constants, but we can fix that. So we can just say, hey, let's just have some nice human readable constants for the key codes that correspond to the keys. So as I said, left is 37, right is 39, and space happens to be 32. Cool. So if the left key is down in this particular tick, then we just move the player left. So let's check that out. Okay, great, that's fine. Everything's okay, don't worry about that. Let's do the right key first. And everything's fine there too, so that's good. So it's not quite fine. So the good news is we're moving the player, and the more good news is that we're drawing at them at their new location. But the bad news is that we're forgetting to clear away the old drawings. And the reason for that is because the canvas has no idea about the tick that we set up. It's just drawing more pixels just adds them to the canvas. So you have to clear them away if you care about that. And it's actually pretty easy to do that. We can just, inside the main draw function for the whole game, just use this nice clear rect function and just clear the whole canvas. So that feels good. So now the player's being their old drawings being cleared away. So we've got our protagonist. Let's add some antagonists, and those are going to be the invaders. So I hope you don't mind. I'm just going to start from the player code just to save some typing. So the invader constructor function takes a game, the game, and a center for the invader. We save away the game again for later use. The size is the same. The center is just whatever we passed in. The update function is pretty different. I'll come to that in a second. And then the draw function is exactly the same because everything's just a square. So the update function, what the invaders are going to do is they're going to be in the sky, 24 of them, and they're going to patrol from left to right. They're not going to come down, they're just going to patrol. And so they'll be at the far left and they'll go like like that, and then coming back and stuff like that in a menacing way. And so we need some variables to marshal that state, right? So I'll make a patrol x. Yeah, patrol x variable, which will be 0 when this invader is at the leftmost point of their patrol, and then 40 when they're at the rightmost point of their patrol. Okay, and then I'm going to have a speed x, which is 0.3 when the invader is moving right, and minus 0.3 when they're moving left. So now the invader update function is just a matter of marshalling that state and then applying it to the position of the invader. So first of all, let's deal with turning around. So if patrol x is less than 0 or it's greater than 40, then we want to turn around. And that's pretty simple. We can just reverse the speed. Like that. And then we just want to add every tick the current speed to the invader's position. That's nonsense. And then we just need to update the patrol x variable to keep track of where the invader is in their relative patrol. So that looks pretty good. Fine. Now we need to create the invaders. Let's make a special function to do that because there's so many of them. So that takes the game. And all it's going to do is create an array of invaders and return it as its work. And so to create the invaders, we just loop 24 times, once for each invader. And then the main work is just to figure out where the invader should start in the sky. So we need an x and a y for their coordinates. So x is just 30 pixels in from the left, plus I mod 8 for 8 columns of invaders arrayed across like that, multiplied by 30, where the 30 is 15 for the width of each invader and 15 for the gap between invaders. And then y is the same, except it's I mod 3 because we only want 3 rows of invaders, like that. And then we can just create the new invader, passing in the game and our new center, and add it to the invaders array. Okay, great. And now all that remains is to call the create invaders function. So we're back in the main game constructor function, passing game, then we just concat on the player. So cool, so what bodies is it's all 24 invaders in an array, and then with the player on as the 25th body to start the game off. And there they are, they're in the sky, and they're patrolling backwards and forwards. So that feels nice. Cool. So we've got protagonists, got the antagonists, that's pretty good. But it's not much of an antagonization without the threat of violence. So let's add some bullets. So I'm just going to do a bit of copy pasting again, save some time. So bullet is just game, center, and also velocity this time. So save away the game, much smaller bullets. Center is whatever we say. Velocity is whatever we passed in also. And then the update function is just very simple. It's just add the velocity to the current position of the invader. So and of course the draw function is just the same again. Okay, great. So now the player is going to be doing the firing first of all. So we can just listen for the space key just in the same way as we listened for the left and right arrow keys. And when the space key goes down, we just create a new bullet. And we know that we are passing in the game, and we're passing in the center of the bullet, which is basically where the player is, except we want to add some small amount to the height of the bullet, or where the bullet is created, so that it's created above the player's head, so that it's not created inside the player, which would be pretty weird. Cool. And then we want a velocity for the bullet. So that's going to be the x component is 0 because we don't want to go left and right, and then the y component is minus for going upwards, and then 6 for a nice speed for that bullet. So that feels good, but when I press space, nothing happens. Now, what's going on? Well, probably what it is that it's all very well to create the bullet, but we want to actually add it to the game, because at the moment it's just a new object that is not having update or draw called on it by the main game. So let's solve that problem. We just want to say, hey game. Oh dear. Let's add the bullet to the game. So add body is a function that we need to write, but it's pretty simple. It's just a very thin wrapper around the push function of the bodies array. So we take a body and we push on the body. Yeah. Okay, great. So we've got bullets. So that feels good. They're not very effective though, because they're just whizzing straight through the invaders. So let's solve that problem. And let's solve it with collision detection. So I'm going to start writing a function here called isColliding. It takes two bodies, B1 and B2, and it will return true if those two bodies are colliding with each other. Now, just going to kind of punt on that definition for a second, but what that code is going to do is it's going to say, hey, are these two rectangles overlapping each other? If they are, then those two bodies are colliding. But like I say, we'll punt on that for a second and go to the rest of the code that's going to use that code. So let's think about collision detection for a second. We're in the main update loop of the whole game. Collision detection is a matter of finding pairs of bodies that are colliding with each other and then having some sort of response to that collision if it happens. Now, the response in our case is going to be super simple, just to, again, keep the code short. It's just going to be to remove the colliding bodies from the game. So if a bullet hits an invader, then both the bullet and the invader will be removed from the game, and that's it. But given that constraint, then we can actually write pretty simple short code for collision detection. Because we can just say, hey, the new bodies for this subsequent tick and indeed all of the rest of the game is just the old bodies where we've filtered out to keep all of the ones that are not colliding with anything. Okay? So new bodies is old bodies where we've kept all the ones that are not colliding with anything. Okay? So we've written the code that we'd like to be able to write. Now we have to write the code to make it work. So not colliding with anything takes a body, we know that, and then it's going to do some sort of check on all of the other bodies, we know that. So what's the check? Well, the check is just, let's go through all the bodies again, and let's filter to keep all of the ones that are colliding with B1. Like that, okay? So let's just work through that again. So B1 is not colliding with anything if we go through all of the bodies in the game and keep all the ones where B1 is colliding with stuff, and the resulting array is length 0. Okay? So let's refresh. Okay, fair enough, B2 doesn't exist. Great. Okay, so that's all well and good, but this is going to do nothing because is colliding doesn't work. So let's just think about collision detection for a second with two rectangles. So for that, I'm just going to go to my favorite artist mode in Emacs. So I've got a rectangle here. Is that visible? Yes. I've got a rectangle here, and I've got another one here, and let's imagine those are two bodies in the game. I know with absolute certainty, like night follows day, that if the right of this rectangle is to the left of this rectangle, then they're not colliding. There's no two positions where those two rectangles can be, where that's true, where they're colliding. Okay? Similarly, I know with absolute certainty that if I've got these two rectangles, if the bottom of this rectangle is above this rectangle, they're not colliding either. Then I can do another check on this side, and of course this time it's the right of this rectangle compared to the left of this rectangle. And then also here too. Now, if I check all of the places where they're definitely not colliding, if any of them are true, then they're not colliding. But if they're all false, they are colliding. Okay? So I can go ahead and encode that logic in code, and it's a pretty mechanical piece of code to write. It's just comparing some numbers with each other. But I feel worried that I'll mess it up on stage, and so I please hope that you'll forgive me when I ask you to take my word for it that that works. Let's find out. And it does, so that's great. So we've got collision detection, so that feels pretty good. Bit of a one-sided battle now, though. The invaders can't fight back, but that's an easy fix. So let's just borrow this bullet code. Sorry about the horrible formatting there, by the way. Let's fix that. Wow, weird. Okay. Okay, great. So the invader is obviously not going to fire in response to keyboard input. They're going to fire in response to some sort of random thing that comes into their head. And that random thing is just basically a dice roll where we just say, hey, let's do a random number, and every time it comes up to be something, then we'll create a bullet. And the bullet that we're going to create is pretty much the same as the one we create for the player, except, of course, we want to create it below the invader, and we want it to go down, not up. But other than that, it's pretty much the same. So this is now good and bad. Um, so what's wrong here? Well, I mean, the good news is that the player can die from enemy fire, but the bad news is that the invaders are shooting their friends. Um, so let's solve that problem and make them a bit more intelligent. So we want to do two checks now. We want to check that this random dice roll comes up, and we want to check that, hey, do you have any invaders below you? And that's a function that we can just, oh, I'm sorry. And do you not have any invaders below you? Cool, so now, before we fire a bullet, if we're an invader, we do a random dice roll, and then we say, hey, do you not have any invaders below you? So let's go and write that function. So this takes an invader, we know that. And we can just loop through all the bodies again and do a filter with some sort of condition. And imagine that this condition went through all the bodies and found all of the ones that were invaders that were directly below the invader that was passed in. Then we could just say, hey, if the length of that array is greater than 0, then that means that there are invaders below the invader that was passed in, and therefore we should just not fire as that invader. So what's the condition? Well, first of all, is B, this body that we're checking at the moment, are they an invader? Second condition, is B somewhere below the invader? And then third and final condition is the B body, is that in the column of invaders, the same column of invaders as the invader that was passed in? So that we can do that with lateral distance. So is the distance between those two invaders less than the width of an invader? If yes, then they must be in the same column. So that feels good. And now that totally works. So that's fantastic. So now just the bottom row are firing, and if we knock out one of them, then hopefully the one above him will take up. There we go. We'll take up the slack. Cool. So that's pretty much Space Invaders. I mean, close enough. I'm just gonna. It'd be nice to have some sound though. So let's do that as the final thing. So I'm just going to hop back to the index.html for one last time. And I'm going to add an audio tag, give it an ID, so that I can grab the sound from the DOM. And I'm going to give it a source tag, which will be the URL to my shooting sound that I'm going to play when the player shoots. So that feels good. So that will load the sound into the browser. Now I just need to grab it in a similar way to how I grabbed the canvas. And now I just need to play it at the right moment. So this is the player bullet creation code, and I can just say, hey, shoot sound. Let's call load on you to rewind the sound, and then play to play. Oh wait, sorry, hold on. Okay, very quiet. Yes? Yes. Great. And that's Space Invaders.